Hi, I'm Sean Gannon, and this is Minute Math. And today we're learning about using logical reasoning and counterexamples in algebra. In this video, we're going to talk about, is something always true? A counterexample with quadratics, domain in real life, function transformation logic, and real-world reasoning. So, when you're ready, let's get started. Consider this statement. If a shape has 4 sides, it must be a square. Is this statement always true? And the key here thing is it always true? If we can find a counterexample where it's not true, just one, then we can say, no, it's not always true. And so if a shape has 4 sides, it must be a square. No, that's not true. Our counterexample here would be, well, a rectangle. A rectangle has 4 sides, but that's not a square. So, no, a rectangle is a counterexample here telling us here that the statement is not always true. Consider this statement. All quadratic functions have 2 distinct real roots. Is this always true? Again, for it to always be true, we cannot find any counterexample where it's not true. So we find one place where it's not true, then we can't say it's always true. And the answer is actually no. Let's look at our function in basic form. F of x equals x squared. If we consider this function here, this function only has one real root. And that is at x equals 0. It touches the origin at that one spot on the x-axis, and then it kind of goes up on both sides there. And so this function only has one real root. Our statement said it has 2 distinct real roots. Is it always true? Well, no. We found a counterexample here where it only has one real root. And so, no, that statement is not always true. A company's profit is modeled by P of n is equal to 5n. What is the domain if n is the number of items sold? So we want to find our domain here. And the thing is, we need to think about this company in general, okay? If it was just this equation, our domain would be all real numbers. But in this context here, we know that we cannot sell negative items, okay? And so we can sell 0 items, we can sell 1 item, 2, and keep going up, but we cannot sell negative items of a product here. And so our domain here is going to be where n is greater than or equal to 0, showing that the number of items can equal 0, as well as can be greater than 0, and that is our domain for our company's profit model of our equation, P of n equals 5m, if n is the number of items sold. Again, the domain is n is greater than or equal to 0. Describe how the graph of f of x equals, in parentheses, x minus 2 all squared, is related to f of x equals x squared. Let's get a quick little visual of f of x equals x squared. All right, we have a graph that looks like this, some sketch. We have our x and our y, and this is our f of x equals x squared right here. Well, what happens here with this x minus 2 inside of that parentheses, and then we're squaring? That's the main difference there. And I always like to think about stuff like this, of when it's in parentheses, I always think of the opposite of what I expect. Okay, so when it's inside, we're talking about left to the right, a horizontal shift. And we have minus 2 there, and so it's kind of like, well, opposite of that would be a plus 2. And there's a big formula for that. For this here, though, we're just going to talk about quickness of this horizontal opposite, so we're going to the right 2 units, and so it's going to have the same shape, but at 2 units right here, it's going to be shifted over. So this is f of x is equal to x minus 2 all squared. We're horizontally shifting, so, or moving to the right, two units. Okay, so we can pick any point on there and slide it over. It's easier when it's the vertex. Here it's 0, 0. Here it's going to be 2, 0. Okay, for the next one right there for this one. So that's how they're related. It's shifted over to the right 2 units. A rectangle has a perimeter of 24 units. Its length is twice the width. Find the dimensions. Let's talk about the perimeter formula first. Our perimeter is equal to 2 times our length plus our width. This is for a rectangle that we're dealing with here, okay? Now they tell us here that the length is twice the width, okay? So length is equal to twice the width. So our length is equal to 2 times our width. And our width is just equal to W. And we know the perimeter, they tell us here, is 24 units. So what I'm going to do now is rewrite our perimeter formula here, 2 times, and instead of length, I'm going to write in terms of just width. 2W is equal to length plus 1W here, and that's equal to a perimeter total of 24 units. Now from here we want to simplify and solve for W. So what I'm going to do first here is add the 2W plus 1W. So we have 2 times 2W plus 1W is a 3W is equal to 24. And 2 times 3W is a 6W is equal to 24. Divide 6 to both sides of our equation here. And our width is equal to 24 divided by 6, which is 4 units. And so now that we have the width, we can find the length. Our length is equal to 2 times the width, and our width was 4. And so our length here is equal to 2 times 4, which is 8 units. And so now we found the dimensions of a rectangle. It had a width of 4 units and a length of 8 units. Let's recap what we've learned. We first started with a basic example of is something always true? Then we talked about counterexamples with quadratics. We had an example with domain in real life. We then talked about function transformation logic. And lastly, we had a real-world reasoning problem. And now I leave you with a bonus problem. A student claims that x plus 2 in parentheses times x plus 3 in parentheses is equal to x squared plus 6. Is this always true? My hint for you is, if it's not, see if you can find a counterexample showing that it's not true. I hope you learned something on using logical reasoning and counterexamples. And as always, thanks for watching.